So here, okay, they are asking draw the structure of dipeptide, okay, with glycine and serine. Okay, so glycine and serine, okay, if you want to know the detail about glycine and serine, so you have to refer to the data booklet. And I told you the data booklet is not going to be given anymore. They will give you the data directly in the question. Okay, so please take note of that. Okay, so I will just put it over here. Okay, so let's paste the image here first. Okay, so here, okay, I want to look at glycine. Okay, glycine is going to be H only. Yeah, so if I draw the structure of glycine, so C, okay, NH2, okay, and then COOH, okay, and then you have hydrogen. So the R group is hydrogen. Okay, the R group is hydrogen. Now, serine, okay, serine also will have NH2, okay, they will have COOH, okay, they must have hydrogen. So the R group, okay, let's actually look for serine. Serine is going to be CH2OH, okay. So serine, okay, CH2OH. So if I want to draw, okay, the dipeptide, okay, the dipeptide, okay, it's better if I draw like this, okay, C double bond O, OH, okay, and then I put the NH2 here, okay, hydrogen and hydrogen. It's a dipeptide, okay, so you just need to show only one, yeah, the product, okay, which is going to be the hydrogen, okay, is going to come from nitrogen, NH2, yeah, and then the OH is going to come from here. Okay, so that is going to be the water is going to come out, yeah, so it's going to be condensation polymerization, which is going to be formation of amide, yeah. So here, okay, if I put it CH and then H, okay, I just can put C double bond OOH, nitrogen, okay, and then, okay, you have hydrogen, okay, and then you have C double bond O, okay, you have C, H, CH2, okay, OH, and then I have NH2. Okay, this is going to be the dipeptide that they meant. Yeah, so the dipeptide, okay, has, okay, if I put it over here, they have the what we call as the peptide linkage. Okay, so this one is the peptide linkage or amide linkage or peptide bond or amide bond. Yeah, that is going to be showing that, okay, this is going to be, if it continues, then it's polyamide. Okay, so this one is going to be dipeptide. Okay, so they mentioned that, okay, the infrared spectrum, okay, of this molecule. Okay, so this is the molecule that they are analyzing. Okay, so I don't think so we need this now. Okay, so I'll just delete this part. Okay, so you see here the infrared spectrum of glycine and serine is shown below. And if you recall, okay, infrared spectrum is a concept that we have learned in AS. Yeah, so don't worry, you are looking at the correct paper, which is paper 4. Yeah, so I told you, okay, if they are testing something from AS, yeah, they will test, okay, but the marks will be around 2 marks or 3 marks. Okay, so please take note of that. Okay, that's why we need to be ready with everything. Yeah, so this one, okay, please remember, okay, I hope you remember the ghost with the peace sign and so on. Okay, all these are going to be identified over here. Okay, so you see here, okay, we have, okay, this E, okay, we have F, we have G. Okay, if I look at this structure, okay, I need to identify certain things that belongs to this structure, okay, that will be seen over here. Okay, that will be shown in this infrared spectroscopy. Okay, so for example, if I look at the molecule, probably I will notice the first thing that I can notice is maybe, okay, this one will be special signal. Okay, so maybe I identify first. Okay, maybe this one will be a special signal also. Yeah, maybe this one also will be special signal. Okay, let me check, okay, whether all these are going to be there or not. Yeah, so what I notice here is going to be you have E, F, and G. Okay, so I need to identify the peak for the using the infrared spectrum. Okay, let's see whether I have the data for the infrared spectrum here. Yeah, so I put the infrared spectrum over here. Okay, so let me bring this over there. Okay. So if I bring this infrared spectrum over here, okay, let's see whether we can use them. Yeah. So here, okay, I have a data where, okay, I am going to have, okay, somewhere E over here, which is going to be somewhere near to 3000. Okay, 3100 or something like that. Okay, if I look over here, okay, look for 3000 something. Yeah, so most probably, okay, if I bring this further a bit, okay, I need to look for 3000. Okay, so if I look for the 3000, okay, I can see that, okay, somewhere here 3000, maybe they're talking about this. Okay, 3000 something. Okay, maybe they're talking about amide or amines. Yeah, 3000 something, maybe carboxylic acid, all this 3000 something also. Yeah, so I think around here ROH, okay, H bonded alcohol and so on. So you can see here, okay, from what I have, okay, the data, okay, I can have, okay, around 3000, okay, the E, okay, you can see this one, okay, it's like something like this, okay, it's quite broad, okay, it's quite broad, so it's not sharp. Okay, so if I look a broad spectrum over here, it's a white, it's going to be a strong peak also. So if I look at that E, okay, most probably, okay, see whether which one should be select. Okay, is it going to be, okay, I have, okay, amide, okay, I have amide, but that is 3300 to 3500, so most probably something like this. Okay, and then, okay, I do have carboxylic acid. Okay, I do have carboxylic acid, which is from 2500 to 3000. Okay, so around there, okay, around there, and it is broad, okay, very broad. Okay, you can see that they mentioned it is broad. Okay, I do see something that is broad over here. Yeah, I don't see like something like this. Yeah, okay, if you last time, okay, the ghost with the peace sign over there. Yeah, I don't see that. Yeah, but okay, if there is also, okay, the alcohol will be around 3200 to 3600. So somewhere here, supposed to be somewhere here. So this is part of it also. Yeah. So if I say E, okay, if I identify E, E belongs to what? Okay, if you look at the marking key, okay, the E is belongs to, you see, they are taking E as OH, the alcohol, okay, and then they are taking NH also. Okay, they're taking OH or NH. So let's actually look at the data here. Okay, if you look at OH, okay, they look at OH, or they are looking at NH. You can select, okay, which one you want. Okay, so either NH or OH. Okay, so they didn't specify, okay, which one, okay, carboxylic acid or alcohol. Okay, but here they just say it's just OH. Yeah, just OH. Okay, just OH. Okay, so it can be carboxylic acid. Okay, it can be alcohol. Okay, because they're together. Okay, they're together. So you just need to identify the bond. Okay, so the bond, you can either identify NH bond, or, okay, you identify, okay, the OH bond. Okay, no need to be specific. Okay, that is going to be, sorry, that is for E. Yeah, so I select here E. Okay, Donna, is it okay?
Yes, sir.
Yeah. So your favorite symbol here, yeah. Okay, but it's not only that. Okay, it's not only the alcohol. Therefore, they are not completely over here because it's combined. Yeah, it's combined. So we have identified that. Okay, so let's actually look at F. Yeah, F is going to be like something like very sharp. Okay, and then somewhere around 1000, maybe. This one is going to be 1000. How many? Okay, this one is going 1700 something, maybe somewhere 1600. Okay, so 1750, so maybe around 1700, around there. Yeah, So if I look at 1700, okay, the one around there, okay, most probably, okay, I don't see any carbon-carbon double bond, so it definitely not this. Yeah. So 1700, this one not within that range. Okay. 1700 most probably within this range. Okay. And most probably that is C double bond O. Okay. So you don't have this. Okay. I think that's the answer then. Yeah. C double bond O. I'll make it bigger. Okay. So you see they are within the range. Okay. To be exact. Okay. To be exact, in this molecule, what range? Okay. I see C double bond O for carboxylic acid, and I see C double bond O for amide also. So it should be either this or this. Yeah. So they didn't ask you to give them the absorption range. Okay. They just want you to identify. Yeah. So the identification is going to be C double bond O. That's it. Okay. So that is going to be the one that will appear in the answer also. C double bond O. Yeah. So, and what is going to be G? Okay, G is around, okay, this is 1250, so it's around 1000 plus lah. Yeah, 1100 around that. Yeah, so 1100. Okay, let's actually look at 1100. Okay, so most probably is it going to be alcohol? Okay, this one. Okay, or 1100. I don't see any other thing. Yeah, so 1100 is going to be the CO bond. Okay, CO bond. Okay, that do I have ester or alcohol over here? I don't see any ester in the molecule, so this is belongs to alcohol. Yeah, they didn't ask you in detail. Yeah, so they just want you to identify the bond, so this belongs to CO. Yeah, so if I put it over here, okay, E. Okay, E is going to show me NH or OH bond, so most probably this OH bond, or it is going to show me for NH bond over here. Okay, or it can be also showing this bond. Okay, we don't know. Yeah, so the OH also can be shown over here. Okay, so the F, okay, is C double bond O. Okay, which is going to show us, okay, this one. Okay, and then G is going to be C single bond O. Okay, C single bond O, which is going to be, you can get it from the here. Okay, which is going to be for alcohol. So this one. Okay, and then this one also. Okay, so these are the information that you can make up from here. Yeah, so just be careful. Yeah, they can still ask you about infrared spectroscopy also, just to confirm more. Yeah, so the next question. Yeah, so if you look at the next question, okay, this is the part. Okay, I think you can ignore certain part. Okay, X-ray crystallography is no longer in your syllabus. Okay, so I will remove this part. Okay, and then okay, this one you can remove. Okay, no need. Okay, and then I don't think so you need this. Okay, you can remove this part. Okay, the rest, okay, are still in your syllabus. So let's actually try this. Okay, so NMR spectroscopy, okay, they can be both used for examining the structure of organic compounds. Okay, so they are very useful to examine hydrogen atom. So they are telling that maybe we use the proton NMR. So explain why NMR spectroscopy can detect hydrogen atoms in molecules. Yeah, because okay, the proton or the hydrogen molecule, okay, hydrogen atom, okay, they have the spin. Okay, proton has the hydrogen atom, since they mentioned about hydrogen atom, so just say the hydrogen atom, okay, has its own spin. Okay, has its own spin, creating, okay, its own magnetic field. Okay, when external field, okay, opposes the magnetic field created, okay, by hydrogen. Okay, energy gap, okay, energy gap or two energy gaps are generated. Okay. So NMR spectroscopy can be used or can be used. Yeah, can be used. Okay, that is going to be the first part. Okay, so that to explain. Yeah, so do remember this first part is only 1 mark, so you need to know. Okay, the beginning part. So here the second part. Okay, they still say molecular formula of this. Okay, but I don't think so. They are going to continue. They say the NMR spectrum below. Okay, was obtained from an organic liquid P. So they are using a different molecule. Yeah, so no need to worry about this. Yeah. So they which contains 5 carbon atoms per molecule. So they have 5 carbon atoms. Okay. So using these 5 carbon atoms, I think yesterday we did something from here. So if you use the 5 carbon atoms, they say that how many protons are present in one molecule of P. So if you want to find the number of proton, you just need to add all these numbers. So number of proton is going to be 9 plus 1, okay, 10. So plus 2 is 12. Okay, 12. Okay, and explain your answer. Okay, they are 3 different environments. Okay, 3 different environments. Okay, and each environment has each environment um, has a few has its own proton. Okay, or the number. Okay, the number of hydrogen. Okay, having each environment. Okay, is shown at the top. Is shown at the top or as numbers in spectrum. So you just need to add 9 plus 2 plus 1 equals to 12. Okay, is the total proton in the sample. So you just need to explain more about it. Yeah. So there are going to be 12 proton. Okay. So if you have 5 carbon, okay, we know 5 carbon, and then you have 12 hydrogen. Okay. So they say that when a little D2O, is added to P, the absorption at 2 disappears. So absorption at 2 disappears. So it means that this absorption can be either NH or it can be OH. Okay, so because of that, okay, they disappear. Because the one that will disappear, okay, is going to be the NH and OH, because rapid exchange, okay, rapid exchange of proton happens for that bonds. Yeah, so rapid exchange of proton happens. Okay, so what does this tell you about the group responsible for this absorption and why? Okay, so we do not know whether it's NH or OH, so we just put it. Yeah, so NH or OH. Okay, I'll just put, okay, it contains NH or OH. Okay, and okay, there is no, okay, the disappearance. Okay, the disappearance is caused, okay, by rapid, okay, exchange of proton with D2O. Okay, and D being even number mass will not give any spectrum during NMR spectroscopy. Okay, or will not be detected. Okay, so that is going to be, you need to explain about that 2 marks. Okay, so what does the absorption 0.9 tells you about the adjacent carbon atoms? Okay, so the adjacent carbon atoms, okay, 0.9. Okay, since there is no splitting, okay, there is no splitting, therefore, okay, I can just say that there is no, okay, hydrogen atoms, okay, attached to carbon atoms, to carbon atom adjacent, okay, or adjacent carbon atom. Okay, that is going to be the conclusion. So what group, okay, or groups are responsible for the absorption at 0.9? Okay, so 0.9, if you have 9, yeah, so do remember, okay, it must be, okay, in form of carbon attached to CH3, CH3, and CH3. Okay, so there's no other things, okay, that can give you 9 proton. Okay, so it must be CH3. Okay, so you just put, okay, the group responsible is going to be CH3, or you can say methyl group. Okay, methyl groups. And they didn't ask you to explain, just that one is enough already. Okay, suggest a structure for B. Yeah, so we only have this part of it. Okay, so this one is done. Okay, and I know this part may be OH or NH. Okay, but I know that this is confirmed cannot be NH. Okay, because now I know it's a high resolution. There is no splitting. If you have NH, there is no just, they are not going to have only NH like that. They will have NH2. Okay, so they are going to be two proton environment. Okay, therefore, okay, rather than saying or, yeah, NH or this, I know that it is going to be OH group. Okay, it is going to be OH group. I will remove the NH. So here, okay, because there is no splitting, it means that I have the OH group. Okay, but I cannot just simply put OH here because I have another environment. Okay, so the another environment is going to be this one. Okay, but they say that they have two hydrogen. So the only way that I can know that they have two hydrogen is going to be carbon, another carbon, and then they share the same environment like this. Okay, if you are not sure, you can still look at the data. Yeah, look at the data. Okay, like for example, this is going to be near to 3, then you look at near to 3 for hydrogen, for the proton NMR. Okay, near to 3, this is going to be proton. Okay, so you can see near to 3. Okay, close to hydrogen. Okay, CH2O, close to 3. Okay, so it's going to be next. Okay, it's going to be CH2 next to O. Okay, so you can confirm that. Yeah, so we are not just simply putting. Yeah, so we do confirm. Yeah, we do confirm. So it means that, okay, you are going to have a situation where, okay, you have, okay, this CH2, and now, okay, and now because there is no splitting also. Yeah, the carbon next to it, there is no direct hydrogen. It is attached to carbon, so there is no splitting also, and there shouldn't be anything over here also. So that is going to be to confirm why there is no splitting for this carbon. Yeah, and then this one will come as OH. Then only it makes sense. Okay, so this is the molecule that we supposed to draw. Okay, that are suitable for this question. Okay, so suggest a structure. This is my structure. Okay, so they didn't specify. Okay, if they ask you to write down in form of structural formula, then you write down, yeah, CH3, 3. Okay, and then you have carbon. Okay, and then you have CH2, you have OH. Yeah, if you want to write like that. Yeah, or this one. Okay, so just be careful. So if you look at all the answers, yeah, you can just double check. Yeah, not in your syllabus anymore. Okay, not in your syllabus anymore. Okay, this one done. Okay, so the group responsible, yeah, see, they do allow. Yeah, if you put the NH, okay, just now, okay, the one that I deleted, if you put NH, is still okay, they do allow. Yeah, so but as long you say rapid exchange, okay, exchange or replace. Okay, so make sure you use that terms. Yeah, so adjacent carbon has no, yeah, no hydrogen atoms, methyl group. Okay, and then you have the structure. So all correct. Okay, so you can see. Okay, even. Okay, so far so good. All right, let's move on. Okay, so here, okay, I think this one also, I hope I discussed with you last time, but yesterday, but it's okay, we can go through again. You see, yesterday I mentioned that, okay, the important stuff that you need to learn is going to be how to use the mass spectroscopy. Yeah, even though they are already in your AS syllabus, they can still ask you similar to infrared spectroscopy question that you saw just now. So there is no rule that they cannot ask. Yeah, so that's why I want you to know about this. Okay, so the formula, I hope you remember the formula. If you want to find out the number of hydrogen, okay, the number of hydrogen, the number of carbon, okay, the number of carbon, okay, present in G, okay, so you just use the formula N equals to 100 divided by 1.1 times, okay, this one all will not be given for you, yeah, so you need to know. So 100 divided by 1.1, abundance of M plus 1. M plus 1 abundance is 2.5 divided by abundance of M, which is 74. You calculate and you will get the number 3. Okay, so this one is important and it gives you the 2 marks. Okay, very important and crucial marks for the rest of the questions. Yeah, so the NMR spectrum of compound G is shown. So they give you this NMR, and you can see that there is splitting. The moment you see splitting, it means this is going to be high resolution, and we are not talking about carbon 13, we are talking about proton. Yeah, so this is high resolution. Use the data booklet and your knowledge of NMR spectroscopy to identify the type of proton responsible, okay, for the 3 absorptions. So we just want to find out, yeah, what this one belongs. Yeah, where does it belong? Okay, where does this belong, and where does this belong? Yeah. So the moment when I see this, okay, it must be, if I see there is going to be something that is going to be a single peak, okay, there is no splitting, okay, most likely, okay, it is going to belong to NH and OH, okay, but we don't know. Okay, let's actually check whether it's true or not. It's around close to 12. Yeah, so let's see whether you have something close to 12 over here for proton NMR. Okay, if I go through here, okay, so let's see, close to 12. Okay, so close to 12, okay, I can see something, okay, NH, okay, close to 12, okay. So I can see OH also close to 12, okay, around here, okay, around here. The rest, I don't see anything that is close to 12. So it's either OH, okay, or it can be NH, okay, which is going to be something like from amide, okay. So OH is going to be from the carboxylic acid, okay, not the simple alcohol, okay, not from the simple alcohol. So OH and NH, okay, so that is going to be the information that I have now. Yeah, so that, okay, if I put over here, okay, the type of proton, okay, that is going to be responsible for 11.8 is going to be either, okay, it's going to be proton attached to nitrogen, or the proton, okay, attached to O, okay, the OH, okay, that is going to be the type of proton that we are talking about. And then, okay, the type of proton, okay, that you have over here, which is going to be, if I look at here, okay, I see the splitting is going to be triplet, okay, and I see the splitting is going to be quartet over here. Okay, it means the neighboring, okay, the neighboring should have, if it is quartet, the neighboring carbon have 3 hydrogen, okay, environment. Okay, if it is neighboring have 3 hydrogen environment, most likely, yeah, they are CH2 attached to CH3. This is my I suspect only lah, okay, because this one must be, okay, attached to this, okay, even though they didn't give you information at the top, okay, I know that, okay, it is actually a quartet, so must be CH3. Yeah, so let's see whether this is going to be belonging 2.2 belongs to something that is attached to that or not, because I know also this one, okay, should be attached to OH or an H. Okay, so I need to know, okay, whether that carbon belongs to where. Okay, so 2.2. Okay, let's actually look for 2.2 over here. Okay, when I look at 2.2, okay, I see somewhere, okay, it's around, okay, CH. Okay, I'm looking for CH2. Okay, then bonded to CH3, and then this one bonded to O, or CH2 bonded to nitrogen. Okay, something like this. Okay, so let's actually look whether there is CO. Okay, nothing like that. Okay, so CO, CH2O. Okay, and it's written 2.2. Okay, here is 3.2. I don't think so. Yeah, I don't think so. This is the one that we are looking for. Okay, so let's actually move on to maybe 2.2. Is it just telling about this CH2? Okay, but this is going to be 0.9 to 1.7. Okay, so let's actually look for something else. Okay, 2.2. Okay, 2.2 alcohol. Okay, OH and H. I think here has to be something from here. Yeah, from CH2O. Okay, or here. So from what I see over here, okay, most likely if I want to select between these two, yeah, I need to select, okay, most probably the alkane, okay, over here. Okay, the hydrogen attached to the carbon, okay, CH2 only, yeah, CH2 only. Okay, if it is next to oxygen, the number is too big. Okay, number is too big. So it's going to be either CH3, okay, or CH2. Okay, so I think let's actually go see whether it's CH3 or CH2. Yeah, so okay, if you look at this value, okay, so I'm talking about maybe hydrogen, okay, attached to carbon that has, okay, C. Okay, the type of proton, just CH2. Okay, let me just write it over there first. Okay, 1.1. Okay, you have 1.1. So most likely maybe the CH3 also. Okay, so 1.1. Okay, 1.1. Okay, this one also around here. Okay, so just now was 2.2. Yeah, so maybe I mix out this one. Yeah, okay, just now 2.2. Okay, you can see alkyl next to C double bond O. Okay, but there is no C double bond O. Yeah, so cannot also. Okay, cannot. Okay, so maybe around here. Okay, so this is going to be 1.1. Okay, I don't see any other 1.1 here. Okay, maybe the OH also. Okay, but we have three, yeah, splitting. Okay, if you have splitting, that one cannot be, we cannot consider this. Okay, most probably that is going to be CH3. Okay, so here, environment of proton is going to be alkane. So we are talking about the alkane, yeah. So here, okay, if I put as answer, okay, so this one may be CH3, this is going to be CH2. Okay, let's actually look at the answer given. Okay, if you look at the answer, okay, they say, okay, if methyl methanoate, okay, so I think, okay, we are talking about ester, yeah. Hold on. Okay, this one is going to be compound G. Okay, suggest G. Okay, if I have 1, okay, if it is 1.1, okay, then we are talking about CH3. Okay, so that one is okay. Okay, so this one is CH3 is correct. Okay, type of proton is CH3. So 2.2, okay, is the one that is going to be CH2CO. Okay, CH2CO, CH3CO. Okay, so they are talking about, okay, there is going to be CH2CO, okay, 2.2. So I think this one, yeah. Okay, they are selecting the one that has C double bond O. Okay, this one, guys. Okay, they're selecting this one. Okay, 2.2. Okay, so they are talking about, okay, most likely they're talking about this. Okay, CH2, C double bond O. Okay, this is what they're talking about. So, okay, if we go there, this should be, okay, cannot be CH2 alone. So this one should be CH2, okay, attached to CO. Okay, CH2 attached to CO. And then the last one, okay, the last one is going to be either, yeah, either you have this structure COOH or CO and H. Okay, so here, okay, I am thinking most likely is going to be COOH. Yeah, COOH. So I'll just put, okay, this one belongs to COOH. Okay, the hydrogen attached to O. Then beside the O, there is C double bond O. Yeah, which is going to be, I can relate with this. Okay, which I can relate with this. Okay, if I don't, okay, I cannot actually relate with that. Okay, so here, okay, most likely the structure that I'm talking about, 3-carbon structure. Okay, this is not the structure. Okay, I'm talking about most probably this structure. Okay, if I draw. Okay, I'm going to draw, okay, this one, okay, most probably there is CH3, okay, and then there is CH2, okay, CH2, then there is C, another C double bond O, and then I have OH. This is the 3-carbon, okay, structure that I might have. Yeah, and the hydrogen, we don't know the total number of hydrogen, okay, because they didn't put it at the top. Okay, so this is the structure that most likely that will be formed. Yeah, so here, okay, the addition of D2O, okay, causes one of these absorption to disappear. Explain why this happens and state which absorption is affected. Okay, the absorption that will be affected is 11.8. Okay, so why? Okay, this is because of rapid exchange, okay, of proton with the hydrogen in OH bond, okay, with the atoms that will not give any NMR spectrum since the mass of the atom is even. Okay, this is based on what I will write during the exam. Yeah, so if you look at the answer that is given to you, yeah, okay, they didn't give you the answer, is it? Yeah, here. Okay, it disappears, okay, because rapid exchange, okay, equation showing the equation. I think no need, they say or, yeah, so no need to, if you didn't mention that, it's okay. So as long you say there is a rapid exchange, okay, there is no marks for even number and so on, I can understand also because it's 1 mark. If let's say they give you 2 marks, then you must mention about the even number. Yeah, so just take note of that. Okay, 2 marks. Okay, if it is 2 marks, this is 1 mark. So draw the structural formula of G. Just now, okay, we concluded that there is this structure. Okay, and then you have CH3, and then this is going to be C double bond O, OH, and then CH2. Okay, so this is going to be the structure that we confirmed just now. Yeah, so the structural formula, so make sure, okay, structural formula CH3, CH2, okay, and then COOH. Okay, this is going to be the structural formula. and several structural isomer of G exists. Okay, so draw the structural formula of an isomer of G with only 2 absorption in the NMR spectrum. So we need to actually draw with 2 absorption. So it means it must have 2 environment, 2 hydrogen environment only. So the one that I can think of 2 environment only is going to be, if I'm going to draw isomer for this, okay, I will think of carboxylic acid. Okay, most probably there are 2 oxygen. So if there is 2 oxygen, another thing that I can think of is going to be, maybe you draw C double bond O. Okay, keep the O here. This CH3 I break and bring it over here. Okay, CH3. Then I bring this H over here, so it will become CH3 over here. This is the first thing that will come in my mind, yeah, automatically. So I will have ester. Okay, I will have ester. Then only I will identify whether this is something that I'm looking for or not. Yeah. So when I see all of them same environment, okay, but if I look at this hydrogen, okay, even though it looks the same, okay, but they are not the same. Okay, because why? Because the carbon is attached to O. This one, the carbon is attached to carbon double bond O. Okay, so they are different. So this is different. So they are going to be 2 different environment. So this is what they want. Okay, what they want. Draw the structural formula. So it's supposed to be CH3. Sometimes, yeah, they like to confuse with the term draw. Yeah, CH3, COO. Okay, and CH3. This is the drawing. Okay, that they want. Okay, some students will still get confused. Okay, they still put it big space over there. Yeah, but if you go and draw something else, okay, forget about that 1 mark. Yeah, you are not going to get that 1 mark. Okay, make sure, okay, you write accordingly. And then, okay, use the data booklet to show where this absorption will occur. Yeah, so this is going to be for isomer G. Yeah, so the isomer G, most probably pick 1 and pick 2. Okay, so we are talking about 2 absorptions. Yeah, 2 absorption must be the hydrogen, okay, that attached to carbon single bond O. Yeah, so it means this is 1 absorption. Okay, another absorption is going to be the CH3 attached to CO over here. Yeah, so we need to look at the chemical shift. Yeah, the one with CO, okay, the one with C double bond O. So let's actually look at that value. Okay, the one, okay, that has C double bond O is this one. Okay, C double bond O is going to be 2.2 to 3.0. Okay, the one with C double bond O, CH3, okay, 2.2 to 3.0. Later I'll copy and bring it over there. Another one, okay, is going to be the one with CH3, okay, but just only 1 O. Yeah, so this one, okay, which is 3.2 to 4.0. Okay, CH3, CH3, and then you have O. Okay, that is going to be 3.2 to 4.0. Okay, nothing else, yeah, involving O. You can see yourself, yeah. So don't get confused so much. It's quite easy. Okay, you just need to bring this. Okay, I'll copy, okay, and bring it over here. Okay, I paste it over here. Okay, so you just need to write down, okay, the one that is going to be, one is, okay, you choose. I think they didn't specify which one. Okay, so you can choose any. Okay, so it's going to be either 2.2 to 3.0. Another one is 3.2 to 4.0. So you can see here, okay, they say if you use methyl ethanoate, which is what we are using now, yeah, so it's either 2.0 to 2.1. Okay, I think this one follows the previous data booklet. Okay, so this one, no problem. Okay, it's not 2.0 to 2.1, it's 2.2 to 3.0. and then you have 3.3 to 4.0, which is 3.2 to 4.0. Okay, the answer is slightly different because different years. Okay, they were using different data booklet value. Yeah, so that is actually something that you need to take note. This is going to be the value that they supposed to be giving you. Yeah. So done this part. Okay, so let's actually move on. Okay, so we still have 7 more minutes. Okay, so modern methods of chemical analysis often rely on the interpretation of data. Yeah, so this is still chemical analysis. So you have electrophoresis and paper chromatography. Yeah, so in each of the case, okay, give one property of amino acid that causes their separation. Yeah. So for electrophoresis, yeah. So what causes the separation for electrophoresis? Okay, there are 2 property. Yeah, there are 2 property, but they are asking one. Okay, but it's okay. Okay, nothing wrong in giving more. Okay, the first property, because I think there is a DC power supply, give the important one first. Yeah, the DC power supply, it's going to be because of the charge. Okay, the charge, okay, of the amino acid. Okay, so depending on, okay, what buffer solution that you use, okay, for the amino acid, they have their own charge. Okay, I have explained more about the buffer solution and the charge in the previous video, which is the other class. So you can actually, once we combine, okay, you can actually check, okay, under question number 1. Yeah, so the charge of the amino acid, and also, okay, and also the MR, okay, of the mass, okay, of the amino acid. Okay, so it depends on that. Okay, so depends on the charge. Okay, if the charge is bigger, faster. Okay, if let's say neutral, they stay in the middle. Okay, if it is positive, they will go to the negative terminal. If it is negative, they will go to positive terminal. The mass, okay, if you have a bigger mass, okay, they difficult to be separated. If you have smaller mass, they are going to be separated easily. So for paper chromatography, this one, remember, okay, in chemical analysis, I went through paper chromatography first. Yeah, what is going to be the property? Okay, the property is going to be 1, okay, solubility towards the mobile phase. Okay, so that is going to be solubility towards the solvent. Okay, solubility towards the solvent. Okay, something that can soluble more, they will travel more. Okay, and then, okay, second is going to be the solubility. Okay, solubility towards, okay, towards the or the attraction. Okay, the attraction, okay, or adsorption. Okay, so maybe which should I use, solubility or maybe solubility? I'll just use both, solubility and adsorption. Okay, adsorption, okay, towards the stationary phase. Okay, so the stationary phase in this, if you remember paper chromatography, stationary phase is going to be the water in the cellulose fiber. Cellulose fiber. Okay, so that is going to be for paper chromatography. So solubility or absorption of the sample towards the stationary phase, which is the water in the cellulose fiber. Yeah, so that is going to be the property. Okay, based on the solubility. Okay, this one is charge and mass, solubility. Okay, I think sometimes apart from solubility, also it depends also on the mass. Okay, but let's see whether they mention about mass over there. Yeah. So you see the size, okay, they talk about the size, okay, which is the MR, and also the charge. So all done, okay. For paper chromatography, okay, it depends on the solubility with the solvent, okay, and the solubility with the stationary phase. So nothing to do with the size. They didn't mention about the size, so it's okay. Okay, so as long you mention about the solubility, okay, and they didn't actually talk about the adsorption, but it's okay. It's good that you put it over there. Yeah. Now, amino acids are colorless. Okay, so how are the position of different amino acids are visible so that measurement can be made? This one also I mentioned, okay, in the PowerPoint slide. You use the ninhydrin spray. okay, this is going to change the absorption under UV light. You should be able to see everything under blue color. Yeah. So neem hydrin spray is going to be used. Okay. So under UV light, okay, UV light, okay, it can be seen as blue. Okay, then you can measure. Which measurements needs to be made in order to identify individual amino acid in paper chromatography? Then you have to use the RF value, okay, and you compare with the database. Okay, if you want to actually mention more about RF value, yeah, how to calculate the RF value, if you have time, yeah, please go ahead, yeah. So RF value is good enough already, and you compare, okay, with the database, okay. So how to measure, yeah, the separation height, okay, and then you divide with the total height of the movement of the mobile phase. Okay, so if you want, some students, I've seen some students, they do drawing, which is accepted also. Okay, but if you do drawing also, don't expect the examiner to check everything from your drawing. Make sure you write something over here. Okay, so the drawing is just going to help, okay, in terms of your answer. Yeah. Okay. So next, okay, so see whether, okay, I think for D, I think it's going to be requires more time, but it's okay. You can see here, okay. If you have, okay, this is going to be glycine, okay. Glycine is neutral, okay, because they are zither ion, yeah, neutral. Okay, if you look at this is going to be, I can see that, okay, this is going to be zither ion, okay, plus with something, there is NH3 plus, okay, so it means that this is going to be a positive ion, okay, for lysine. Okay, so the presence of NH2, yeah, extra NH2 is going to tell that they are basic. Okay, and then, okay, if I look at this is zither ion, okay, the moment I see this one, this is going to be presence of carboxylic, extra carboxylic acid group. Okay, so it means there is going to be negatively charged, then this is acidic. So why this one is important? Okay, because it determines what kind of buffer that you use. Okay, the buffer that is used for this is going to be acidic buffer. So pH must be lower, yeah, the buffer that you use. So it must be acidic buffer. Okay, acidic buffer. And this one is going to be, you must use the higher pH, okay, which is going to be the basic buffer. Okay, this one you will understand more if you follow my first question and second question. Yeah. So once you have this, okay, when you put the spot, okay, the one that will go to the positive terminal must be the negative charge. Okay, so the negative charge is this one. So glutamic acid. The one that goes to the negative terminal must be positively charged. So this is lysine. The one that is neutral will stay in the middle. Yeah, so the one that is glycine. Okay, so that is going to be the answer. Okay, so glycine. Okay, and then lysine is going to be lysine and then glutamic acid. So you don't just look at glutamic acid, it is acidic. Yeah, don't look at like that. Okay, you have to determine based on the, okay, you cannot all the time depend on that. Okay, you need to determine based on the molecule itself. Yeah, so this one, the paper chromatography and so on, I think the next video I will actually discuss with that. Yeah, so that's it from me today. Okay, so I will stop recording.